Alright, so what happens in chemical reactions? This is our video for today, and this will be our last of our chemistry notes. Remember that in a chemical reaction, your atoms that make up your reactants, whether it's elements or compounds or elements and compounds, the bonds get broken, everything gets rearranged, and you get new products. And you can have a single product, so a very complex product, or you can have multiple products. And this happens in 4 ways that we're going to look at today. And the first one is called synthesis. And if you think about a synthesizer, which is an instrument that can produce multiple sounds, you get this idea that synthesis means to put it all together. And the key word there is all together. And so in a synthesis reaction, if you look at the example that's given, you've got iron plus oxygen, and you only end up with one product. So whatever you start with, you're putting it all together to end up with one product. So you won't see any plus signs on the product side of the equation. You will only see one product, and that's how you recognize it. In a decomposition reaction, it is the opposite of synthesis. It is the reverse of synthesis. So you have one complex reactant that you are starting with, a compound, in this example, potassium chlorate. It is breaking down to its parts, the compound and the element that made the larger molecule, so potassium chloride plus oxygen. So you can recognize decomposition because you start with only one reactant. You have no plus sign on the reactant side of the equation. Think about what decomposition is in nature. It's when something decomposes and breaks down to its parts. And ultimately, say a raccoon gets killed on the side of the road, kind of gets thrust off into the ditch. You know, the tissue, the bacteria decomposes all of the tissue and then all of the organs, and you are left with the bones. You are left with, break it down as far as it can go. So it is decomposing. Now, the other 2 types of compounds, I use the example of going to the movies, and a couple is going to the movies, and she calls her best friend and says, "Why don't you meet us there?" So the 3 of them go to the movies. So here you've got aluminum, which is the best friend. You've got copper chloride, which is the couple. Something happens at the movie, after the movie. A couple of days later, you and your boyfriend are broken up, and your best friend is now with him as a couple. So aluminum has replaced copper in the relationship, in the compound. And copper is all by itself. And we're going to do some demos to show these reactions happening later this week. And you're going to do one today. But so copper has been kicked out of the relationship. And so you see that copper is now by itself on the product side, and aluminum chloride is the new compound. And then double displacement. Sometimes you'll hear the word replacement instead of displacement. Similar meaning, just whichever source you're using. But in this, I call it the double date gone bad. 2 couples go to the movies on Friday night. Everybody gets in a big argument after the movies over ice cream. Next thing you know, on Monday morning, sodium and hydrogen have switched places, broken up. Hydrogen is now paired with chlorine. Sodium is now paired with hydroxide. So the double date went bad, and now you've got 2 new couples. So you end up with 2 new compounds in a displacement reaction. So the difference between the 2 displacements, I have to know the difference between an element and a compound to recognize what's happening. Are 2 elements getting switched, or it's just 1 element getting switched? If 1 is getting switched, it's single displacement. If 2, then it's double displacement. So look at this image to see if this helps. So in synthesis, got the boy and the girl, so the single element plus the single element come together to form a compound, more complex product. Decomposition, the opposite. You've got the couple, the boy and the girl together, then they break apart, and they have decomposed into two elements. Single displacement, you have the one young man by himself, you have the couple or the pair, then you have the young man in the wheelchair is now part of the pair, and the boy in the purple shirt is all by himself. He represents the single element that got replaced or displaced in the pair. In the last one, double displacement, you've got two pairs, and then if you notice that the boy in green switches places with the girl in blue, and you end up with two new compounds. So double displacement. Now, we're going to look at some of these together. One way to think about this is to think about it by color coding our elements and our compounds. So if you've got some colored pencils, get them, or you can get my crayons off the counter that are nearby, and we'll put those out on the table, and we're going to do some practice with these.